Let's talk about time zones.
Oh, good idea.
So, time zones and times in MySQL. SQL 2003 ISO standard. There are date time data types and standard attributes. Those are the data types. The standard data types are actually supported by MySQL. It's date, time, and timestamp. The standard attributes are not supported by MySQL. Those standard attributes are with time zone and without time zone. Hence, the problem of how to deal with time zones in MySQL, because you can't actually just say, hey, this is, 7 p.m. Eastern Standard Time. Right? You have to somehow either store it with an offset or whatever. There's no way that MySQL can store it with an offset that's visible to you.
I was going to say, is there a meaning to the paren p?
Is there a meaning to the paren p? Probably. I think it's precision, maybe. I don't...
Okay. I think time and timestamp are the number of seconds since midnight and Unix epic, respectively, I believe.
No, timestamp is a date time kind of, yeah, but its timestamp is epic time, yeah. So we'll get to, MySQL has additional data types. It has year 2 and year 4 and date time. So it has both timestamp and date time. Whereas other things like Oracle and whatnot just have timestamp. So you have year 2 if you like Y2K issues, and then you have year 4, which is the default if you don't specify any year. So if you specify just year instead of year 2 or year 4, it's going to be a 4-digit year. If you specify year 1 or year 7 or year 3 or year 5, it defaults to year 4. So basically we have year 2 or year 4, and that's, anything that's not year 2 is year 4. So let's talk a little about the MySQL date time data types, because size and range may be a reason to use them or not. So the date data type is 3 bytes. It can go from January 1st of the year 1000 to December 31st of the year 9999. Date time has a similar range. It adds time. It's 8 bytes. So it goes from January 1st, the year 1000 at midnight to December 31st, 9999 at 11:59:59 p.m. Timestamp is smaller. It's 4 bytes. So you could say, okay, what's the difference between date time and timestamp since they both hold date and times? One of the differences is the size. The other is the range. So timestamp is based on the Unix epic. It starts at January 1st, 1970 at midnight and goes until it runs out of 4 bytes, which is, here's the Unix Y2K in January of 2038.
That's a bitch of a one.
Now, does date time also store sub-second increments? I thought there was a data type that also stores milliseconds.
There are, I think it's actually microseconds.
Claim that.
I didn't put that in here because really, do you really need microsecond precision? Some people do. Most people, they just want the date time, like, I made an order on Amazon.com. What time did I make that order? I don't even really need seconds,
Agreed. It's a GPS data, as some folks are asking about it.
So a microseconds part is allowable in temporal values in some contexts, such as in literal values, and the arguments to or return values from some temporal functions. So microseconds are specified by a trailing dot UU part in the example. So you can have select a microsecond of that thing, but they can't actually be stored in a column of any temporal data type. So date time and timestamp don't support it.
It's like trying to store a float into an integer. It just simply ditches the...
Right. Well, it says as of MySQL 508, conversion of a time or date time value to a numeric form, for example, by adding 0, results in a double value with a microseconds part of .000000. So I think that it's not as a string, as a number. It can do it. But if you're not storing it as a number, you're storing it as a date or a time, date, time, or time, then it will just discard it.
But this is just storage. It is not the time resolution really.
Right, correct.
So the time resolution probably much low. Larger or smaller. Not so close as microseconds. Yeah.
Yeah, like if you do select now or select current timestamp, you just get seconds. You don't get microseconds. So timestamp is 4 bytes. Now the time field is 3 bytes. This is not necessarily clock time. It can be elapsed time, which is Happens to be what you can get in 3 bytes. It's approximately a month's worth of time.
The resolution is to the second?
The resolution is to a second, yeah. Now, you'll notice that actually date plus time can give you the same range as a date time, but it's 6 bytes instead of 8. So if you have 2 fields, 1 date and 1 time, that might be a good way to do some things. But if you needed to search on, both date and time, you need to join them together. Yeah?
I'm kind of new to this. I've been using just a numeric field, a 10-digit numeric field, storing a time in there, instead of using date time or any of these other things. Then I use PHP then to manipulate it in whatever way I want. I can get a date or time or
Are
combination.
you using like Unix timestamp?
Yeah. So
Okay.
it's just a 10-digit thing, and so grabbing it in PHP and stuffing it in there. Is there a reason I shouldn't do that? I should use date time?
So the question is there a reason to use, say, timestamp? So if you use timestamp, it's the same 4 bytes, because an integer is 4 bytes, and it's the same date range. Is there a reason to use date time instead of timestamp? There's a whole bunch of them. One is if you need to store any dates earlier than 1970.
Depending on how I'm going to use that particular table, if it's something that I know I'm going to be examining manually just to look at quickly, like a log file or something, then I'll put it in as a date time because I just want to see the human readable version of it.
Right.
But
Right.
for other things, I'd use it as the Unix timestamp to get around the daylight savings time.
Also, it is much better arithmetic.
And it's easier to add.
Easy to add. You can use it as just your index.
Well, MySQL has a whole bunch of features to do
Yes.
to do subtraction and addition. First of all,
Yeah.
it actually can use Unix time, so it has from Unix time.
Yep.
But if I do something like select time diff of, let's say, now, and then 2009 10:01 00:00:00, time diff is not what I want because it's gonna max out. Let me give it December 1st because I can only have up to negative 838 hours, which is about a month. So it's 331. So right now we are 331 hours, 21 minutes, and 1 second past December 1st. And how far are we past, January 1st, 2010, we're negative 412 hours. So we're still closer to December 1st than January 1st at this point.
Oh.
But time diff does work. There's also date diff.
Yep.
So you can use date diff and time diff. So you can kind of get those, that kind of subtraction or whatever. It's not perfect. So yeah, so time is elapsed time, and then year 2 goes from 00 to 99. Year 4 starts at 1901 and goes to 2155 because it's 1 byte, so you get, 255, 256, or 55 or whatever values. So they started at 1901 instead of 1970. Okay, sure. But again, if you needed to store a year that was before 1901, you couldn't use year 4, you'd have to use just a regular int perhaps, but maybe a small int. So time zones in MySQL data types are not supported, as we said. You can't say 5 p.m. Eastern Standard Time. However, another difference between timestamp and date time is that timestamp is transparently stored in MySQL in UTC. You don't see it, but if you have, let's say, 5 p.m. on May 2009 is stored when the time zone is set to Eastern Standard Time, and later the time zone is changed to Central Standard Time, the value retrieved will actually be 4 p.m., not 5 p.m. That's in date time, not in timestamp.
And Java allows you to do that conversion. They have just function for getting out
Yeah.
of timestamp.
MySQL has those functions as well, although not from getting out of a timestamp. So, but you don't store a timestamp. So what I've done here is I've created the table time test. It has a timestamp field and a date time field. And engine equals MyISM because it's not like I'm going to be doing a ton of stuff here. So now I'm going to insert the same value now into time test. So both the timestamp and the date time have values now. If I do select star from time test, I get December 14th, 2009 at 7:24:39 p.m. That's the same on both, even though one's a timestamp and one's a date time. So now what I'm going to do is I'm going to stop MySQL, I'm going to change the host time, and I'm going to restart it. Stop. Okay, it stopped. Now I'm going to go to the time zone, and instead of Eastern time, I'm going to go to Alaska time. Apply. So right now, it's 3:25 p.m. Everybody about ready for their 3 p.m. brownie break?
Yeah.
Now if I start MySQL again, and reconnect, and do a select star from time test, the date time still says 7:24 p.m., but now the timestamp field says 3:24 p.m. Yet another reason why would you use timestamp versus date time is because, well, if you ever change the time zone on your server, it will change your timestamps in your timestamp fields. Yet another reason, by the way, which I didn't mention, is if you do a show create table time test, you'll see this. By default, the timestamp field is not null, defaults to current timestamp, and on update current timestamp. You can change that. You can basically have it not do a current timestamp on update or not have it do a current timestamp by default. So another reason to use timestamp, besides the fact that it's smaller and if you're just getting whatever time now, is that you can actually have these automatic features without having to do a separate trigger or anything.
You can't turn off default current timestamp.
But you can insert stuff into it.
You can give it something other than current timestamp to put in there, but you
Right.
can't.
Can you make it null?
No,
No?
no.
All right,
I
well,
also
you can
found
give it
that
a
out
zero.
because what happens is you have to put something in there, or you can have it default to all zeros, and almost every Java-based client that talks to MySQL pukes with a null exception pointer when it sees all zeros in a date field.
Right,
So
yeah.
it's one of these things that I'm looking to get past in my project.
Let's try putting null into the timestamp, so you can have.
Sure. Insert into time test, TS, values, no. But it says, yeah, this is, I know why that did this. It says timestamp not null. So what did it put in there?
The default.
And indeed, it put in the default. Even though there wasn't even a warning.
Nope.
I put a null in there.
Now, what happens if we create another field and we don't declare as timestamp, don't declare as not null?
So if I do alter table time test, add column, TS2 null or default null or something,
Yes, it will override that. Oh,
you have an error in your syntax.
No.
I
You
want
have
to
to
put
put data
timestamp.
typing.
Invalid default value for TS2.
yep.
So it must be
It must be default
not
current
to not
timestamp
null.
or a specific timestamp. You don't have to put 00, you could put 1970-0101.
Unless the Java client have some other problem with
Right.
Well, yeah, I'm hoping that's not the case.
Right. So
Well,
there is no good null value for a time in Java,
No,
for a
but
timestamp in Java.
it. Yeah, but the problem won't be that it's null, the problem will be it tries to do something with that date, and then you get logically correct results for that date.
Right. So let's talk about time zone. When MySQL starts, when the server starts, MySQL-D, it finds the operating system time zone and sets the system time zone variable, right? So we knew that when we restarted MySQL, it got the new time zone. So if we do, let's see, select, add at global.timezone. That's another way of saying show global variables like time zone with a quote in there. There's also the system time zone. So if you do show global variables like % time zone, the system time zone is actually Alaskan Standard Time, which is what I set it to on the thing, and then the time zone in MySQL is the system time zone. by default, the time zone system variable is set to system, and the system time zone is used. If the operating system time zone changes, MySQL needs to be restarted for the MySQL timestamp variables to change, like you saw. That includes things like select current timestamp as well.
Can you set that variable,
Can you set what variable?
the time zone variable?
Yes.
So you could also, instead of restarting MySQL, you could simply set the,
I could, but it's best if you're going to stick with the system. I mean, if you're going to play, we'll talk about playing with the global time zone and the session time zone, because you can play with those too. So we're gonna talk about that later. But for now, we're just kind of going with the basics of even just a regular timestamp field. Even if you don't play with anything, you realize, oh my God, my servers are in Eastern time, and I want them to be in UTC. So I'll just change my operating system. Let me shut down MySQL properly. I'll update the time zone. I'll restart it. All your timestamp values are going to be changed because they were stored originally in Eastern they were stored in UTC, so they took into account the offset when you stored them.
and then also,
Right. Which is not something a lot of people realize because they think, okay, the only difference between timestamp and date time is number one, the amount of the range and the size, and number two, the fact that I can have the defaults, on update current timestamp and default current timestamp. Most people don't realize that transparently timestamp is stored in the database as UTC. You can't see what value is stored there. You only see the display value based on what your time zone is in your session. So I can actually do, set session time zone equal to, let's say, an offset of negative, let's say, 3 hours. Right, so I'm not setting it to a named time zone. We'll talk about named time zones later. But now if I select current timestamp, right, it's now 3 hours ahead. And if I select global time zone, it's the system. If I select session time zone, it's now 3 hours offset from Greenwich Mean Time, or UTC. So if I actually change this back to Eastern Standard Time, let's say Eastern Standard Time, apply. Now it's 7:32 p.m. again. Now prove to me that the current timestamp is still right in -3. Well, it still is. It's still 9 p.m. -3. Because the global and session time zone and then at global system time zone. The system time zone hasn't changed. Show variables like show global variables like system time zone. And I had to put quotes around it. So it's still Alaskan Standard Time, even though I changed it back to Eastern Standard Time. It won't change again until I pick it back up when I restart MySQL, because it only looks for what the system time zone is at the start when it starts up. Again, if the operating system time zone changes, MySQL needs to be restarted for that timestamp data to be changed, and only the timestamp data type fields change. And I'll say that again because again, this is still 7 p.m. So it's 7 p.m. If you have a date time and you've got, some data coming in from a central server time and something from Eastern server time, 6 p.m. Central is the same as 6 p.m. Eastern, because it's 6 p.m. If you store it in a timestamp and you look it up on you insert it on a server that's, Eastern time, and you look at it on a server that's Central time, it's using absolute time. It's saying, okay, if it was 5 p.m. in Eastern time, it's 4 p.m. in Central time, right? So it's not the same, or 6 p.m. in Eastern time is 5 p.m. in Central time, so 6 p.m. Eastern does not equal 6 p.m. Central. So the question is, if that were the only difference, would you use it? What would you use, timestamp or date time? Well, it depends. In some cases, you would want it to change. In some cases, you wouldn't. It makes converting time zones a whole lot easier. You can set the session time zone. So if I set the session time zone equal to an offset of, let's say, +2 hours, so it's like Central Europe Standard Time, then again, these have now changed, the timestamp's changed, but the date time is still 7:24 p.m. So it depends on the behavior you want. And you're gonna have to, this is important for things like reporting. If you have a reporting slave and you set a session time zone or the time zone is different, the data is actually accurate, but you're viewing it in a non-accurate way because you're changing, it's a different system time zone.
Well, in our case, we're running a website that's viewed by people in 3 different time zones. And their devices are in the same time zone with them, but they're all reporting against one MySQL server. So what we have to do, what we're doing right now is we're basically jumping around this whole mechanism. The guy that wrote this is like trying to circumvent this whole system, which once we get version 2 out the door, I'm gutting it, and I'm going to replace it with session variables all the way across, so that so everything's going to be stored in UTC, and the server's going to be running UTC, and then when people log in to see their data, part of their profile has which time zone they're in, and it'll just simply readjust all the dates and times. So they're using timestamps for the entire application. And it'll just solve that problem once.
There are very easy ways to do that in MySQL, and I have examples later on how to do that. So getting the current date and time. I didn't mean date time as the date time data type or whatever. Current timestamp is the ISO SQL 2003 standard function, and it's supported by MySQL, right? Now is an alias to current timestamp. A lot of people use now because it's a lot shorter to write than current timestamp, but it acts the same way. It's just an alias. It's just a link to current timestamp. One of the things about now and current timestamp and now is that it's replication safe. What that means is it's calculated at the beginning of a statement, and throughout the statement, whenever now is called, you get that value. So if you do an example like this, and I can show you on the screen in real time, but you get, you do select now, sleep 5 now, you get the same value even though there's been 5 seconds that elapsed between the time that it evaluated this now and the time that it evaluated this now. So, not that it really matters and I have to prove it to you here, but I did. Now again, I've mucked with my time zone. But again, I have now and now it's the same thing, which is not necessarily always what you want. If you were trying to do something like select now and a complicated, thing, and then whatever, you're getting 10 different rows and you want a different, a different time each row to see how long it takes to process this row versus that row, it's not really going to work.
Is there another function that's daily behavior?
There is indeed. That function is actually sysdate. So if you do select sysdate sleep 5 now, you get sysdate executes when it executes. It's reevaluated. So there's a few interesting points to make. One is that now is more optimized because it only runs once per function. Whereas this, right, we have 238.27 and 238.27. Didn't I sleep? Oh, I did now. Ha ha ha. So now you can see when I do it right, we have 238.51 and 238.56. So it's 5 seconds apart. So the two interesting points are that, number one, sysdate you actually evaluate it twice, so that's more work. But again, that's what you want in this scenario. Number two, it's not replication safe, which means that if you're using sysdate and you have one server on, your master's in Eastern Standard Time and your server's in Pacific Standard Time, and you replicate sysdate, you're going to get time values 3 hours apart. And if you do something like checksum your data, the checksums are going to come out wrong.
Why on replication is now safe?
It just happens to be because of the way they programmed it in MySQL. Now is, because it's calculated at the beginning of the statement, what they do is they calculate at the beginning of the statement and they put it in the binary log. So you'll actually see in the binary log, it'll say set timestamp equal to, a Unix timestamp. There's also UTC timestamp, which is, it's also replication safe. It's based on current timestamp, and basically it takes, the current timestamp and the session time zone and gives you the UTC timestamp. So if you use, select UTC timestamp, then it's, you know, midnight 40. If you're using statement-based replication, it's non-deterministic. If you're using row-based replication or mixed replication, and you have a statement like this that's non-deterministic like sysdate, it's actually going to use row-based replication so that you get that matching thing.
But in row-based replication, the sysdate still, or
Nope, in row-based, it
it's
moves
all-
the data.
it moves the data always, okay.
And in mixed, it uses statement unless it's non-deterministic, and then it uses row-based. So UTC timestamp, you know, and again, you can do something like time diff UTC timestamp current timestamp to see your offset. And it happens to be 2 because right now I'm +2 in my session time zone. UTC timestamp is based on current timestamp, so it also does this, you know, if you do select UTC timestamp, sleep 5 UTC timestamp, you'll get the same value. Again, it's compiled once at the beginning because it's just the timestamp value minus the offset to get back to UTC. So we talked about sysdate, it's calculated on an as-needed date basis, so if you want to have the same values on master and slave, we actually run into a lot of people who have experienced Oracle DBAs who are just using sysdate because that's what they use, and they have different time zones, and they didn't want different dates on their master and slave, they end up getting it. You can make sysdate act like now, though. If you're worried about this and you don't want to change all your code and whatever, you can actually use the sysdate is now static system variable. So you have to put it in the my.cnf or restart MySQLD with this command. You have to restart the server. It does not take effect automatically. There's no variable for it, unfortunately. It doesn't show up in show variables or show status, so you can't even see what it's currently set to. You have to basically look into the my.cnf. It will make sysdate act like current timestamp and now, meaning that it's compiled once at the beginning of the thing. It just changes the alias from use the sysdate function to, you know, use current timestamp. The default is that it's off. So the default is that sysdate is different from now and current timestamp. So if you have different sources of information, let's say your web or application servers are in a different time zone than each other, or that they're in a different time zone than the database server, that can cause a lot of problems, right? Or even if the person's local time. You know, if I go and make an order on, you know, what is it? Oh yeah, December 31st, 2009 at 10 p.m. EST from Amazon.com. Does that count in Amazon.com's fiscal year 2009 financials or fiscal year 2010 financials? You know, well, it's probably 2009 because they're probably based in California and they just have everything in PST. But it's a pretty valid question. You know, if your web server is in GMT and database server is EMT, you know, an order comes in here. If the database server determines the time, the order would be logged in December 2009. If the web application server determines the time, the order would be logged January 2010. Now again, it doesn't necessarily have to cause a problem as long as the straddling point, like as long as your midnight time or whatever it is, your break point is the same every day, then you're fine because, you know, it doesn't matter if you restart, you know, something at if a new day starts at midnight or at 8 p.m. or at 8 a.m. as long as you still have 24 hours in one day. As long as you don't change it in the middle somewhere, because then your reporting will be like, well, how come we only had half the volume? Well, we changed, you know, the time of a day that restarts from noon to midnight. So we lost, you know, this is only half a day, even though it says it's a whole day. So ways to convert in MySQL. Convert TZ is awesome for converting times. So what you do is convert TZ will actually convert with time zone aware stuff. So you basically have you convert a time. So there's 3 parameters you give it: the time, what to convert from, and what to convert to. Okay? So here, if I convert from now, and let's say I'm saying now the offset is you know, -5 hours, so Eastern Standard Time, and I want to convert it to UTC, or that's GMT, but there you go. So if I do select convert TZ, now first of all remember that right now, the value of now is in GMT +2. So maybe I don't want to do that exact statement. Maybe I want to do select convert TZ now, let's say at session.timezone, comma, plus 0, 0, 0. You have to do plus or minus 0, you can't just have 0, or it gives you an error. And it now gives me, midnight 48, because the session time zone, it converted it to the right time. If I wanted to convert it to -5 and say, well, what time is it Eastern time now? It did the right thing, because now is always in the session time zone. Now, if the session time zone is null because you haven't set it and it's just the default, this isn't necessarily going to work. But if you're playing with the time zones because that's what you want to do, this will always work and it will be good. If you're doing something like storing the offsets with the time. The offset is from UTC, not GMT, because Greenwich Mean Time, there's also British Summer Time. So Greenwich Mean Time itself is like Eastern Standard Time, right? Eastern Standard Time doesn't go into daylight saving time. Eastern Time goes into daylight saving time, right? It's EST some of the time and EDT some of the other time. In the same way, if you live in, I think Liverpool, England is a good one. You live in Greenwich, England. How about that? Greenwich is a good city to use. If you live in Greenwich, England, half the year you live on GMT and half the year you live on BST, which is British Summer Time, which still has so you still have the daylight saving time in Britain. And it can wreak havoc. You guys were saying before that you store it as Unix timestamps so that you don't have those problems.
Yeah.
But it's, it can wreak havoc if you're using time zones, even if you're using offsets and stuff, you'll get two 2 a.m.s in the fall and one day where you have nothing. If you're doing reporting by day, it all evens out anyway. The day DST occurs is different for different countries, so that's also another problem. You can't just say, oh, it happens here, and they change it. Some countries change it all the time. Some countries change it every so often. So
The other thing to note too is that our reporting devices, they report GPS time. It is necessarily UTC that we're getting out of the device, and for an hour every fall, they will report times that don't exist because the server jumped, and when it's going back and saying, oh, I have a reading for 2:10 a.m., the server says you can't have a 2:10 a.m. on the night of daylight savings time.
yeah, that's actually spring. Yeah, spring ahead, fall
spring
back.
ahead,
Yeah.
But for an hour out of a day, out of a year, we get a bunch of
And the other question is,
back.
if it's 2:10 a.m. in the fall, which 2:10 a.m. is it?
right, which is why we're moving everything to UTC, and only at the presentation to the user do we do the conversion. So because all of our devices are all collecting UTC, not GMT, UTC.
But how do you display it to the user when that time didn't exist?
The device blows up and that's it.
Yeah.
Yeah.
Okay, that's good enough.
Well, you have to convert it using time zone aware
Right, which is
conversions, which
well,
is
we would use the session. We'd use the session variable and let MySQL handle it.
right. So you would set at session dot time zone equal to, well, you would set it to whatever it is, right? But
Right. The server would default to UTC, so all the
Right, so
regular
you would actually do
automation
this.
processes.
you would actually assume everything's in UTC, and then convert from UTC to the session time zone.
Sure. Or we would just set the session time zone, and it just corrects all the dates and times, so it's local to that person for all the automated
If
stuff
you
for
use
like
timestamps.
and everything's timestamps already.
It works for functions that use timestamps, such as current timestamp, UTC timestamp, and now. And it works for sysdate, obviously. But it doesn't, and it works for retrieving and storing timestamp fields, but it doesn't work for retrieving and storing datetime fields.
Right.
You can still use, so convert TZ specifically is convert, time zone aware stuff. So ways to convert time, so if you have these offsets, the offset is from UTC, so it's not subtract 5 from the current time. It's, I'm telling you the time is an offset of -5, and now give me an offset of 0. Now, this is kind of dumb, you might say, because you're telling it what the time zone is, right? But we'll actually see a little bit later where you don't have to use offsets, you can use named time zone, like Eastern or EST or EDT. We'll see how to do that later, but for now, even if you don't, because by default you can't use named time zones like that. By default you can use offsets, so you can always use offsets. So if you had a table where you stored the offset, then there's no problem doing this thing. And I have an example later of that. Maybe it's now. So there's a bunch of different approaches that you can take. The first approach is the it's all local approach, which actually takes a little bit of work. You just store the times and dates as the local time. So 6 p.m. Pacific time and 6 p.m. Eastern time are considered the same time, right? And that pretty much works for, let's say you're an insurance company and you want to know how many midnights somebody spent in the hospital, right? So if they spent overnight, it's because they were there at midnight. That's how it's defined in the healthcare industry. So, you know, my insurance company wants to know how many days did Sherry spend in the how many nights did she spend in the hospital. You know, they have to do a search on how many midnights. Now, whether I spend a midnight in the hospital in MGH here, or if I spend a midnight in the hospital in Pacific time, it's still a midnight, and it has to be midnight local to Pacific time or Eastern time, whichever hospital I was in. So that, you know, that kind of application would need to store that locally. This can skew reporting, particularly when you're estimating, say, peak usage time of your site. If your web server's in Texas and you want to know what time is peak usage, you may or may not care that it's 6 p.m. Eastern time, 6 p.m. Mountain time, 6 p.m. you know, Pacific time. You don't care. You want to know that peak usage is 6 p.m. to 10 p.m. Eastern time, or 6 p.m. to 9 p.m. Eastern time. If you just say 6 to 7 p.m., because that's your peak usage time, you're not really getting the sense that it's a 3-hour period, because it's 6 to 7 p.m., you know, local time. It's also problematic when the reporting or the user's perspective changes to a different time zone, right? Now this isn't a problem with that insurance example because they care about midnight, right? But let's say you store my, you know, I don't know, last login time as locally with, you know, and again, the idea is you're not storing the offset, you're just storing local time. You don't care about the offset, you've already done whatever conversion you need to do. And it can be problematic when I change to a different time zone and it says last login, you last logged in, you know, 1 day and 12 hours ago. And I'm like, well, I was asleep then. Oh, no, wait, I was asleep here, but if you take into account the fact that I was halfway across the world, it was, you know, the same 6 p.m. Let's do some conversions. I said I would get an example of here. So I actually, it shouldn't be ST daytime, it should be DT daytime. So what I've done here, oops, is this, but I actually want to change this to varchar 64, not 6. So I'm creating a table here where I have a date time, and a tiny int of an offset, that's why it's OS, and then a time zone varchar 64. Okay, now I'm going to insert into the times. Now this would actually be, you know, 2 different inserts. But basically we have here, now this was a date time field, so it's not going to change even if my session time zone changes, right? Because I want to show some conversion effect. If you store it with the user's time zone, right? So let's say somebody does something at the same, somebody in Eastern time and Central time does something at the same absolute time, which would be 5 and, oh no, -6 is Central time. So same absolute time. So in Eastern Standard Time and Central Standard Time, 2 people bought the same, you know, present on Amazon.com. This is the offset is -5 from UTC, and the offset is -6 from UTC, right? Now there's nothing special about this, right? There's just a date time, a number. It has special meaning to us, but doesn't have special meaning to, you know, anything else. And if I really wanted a real offset, I would probably use some kind of a float, or actually probably a time field, because, you know, India is 10.5 hours off from us, and I can't show that. So I could probably use a time field. And then I just put EST and CST here. I didn't put any specific. It could be EDT, it could be Eastern time. It doesn't have to be anything real. So what I can do is actually I can use the time diff to get offset if I need to get this offset. How do I get the offset? Well, I use time diff, right? And you don't have to say now from UTC timestamp. You give the timestamp that the user saw. So the program would convert, you know, the local timestamp from Texas to whatever the user in Central or Eastern time might see, and then displays that, and then would store that. So instead of time diff now, it'd say time diff with the string of the right thing. Now, one of the things that you can do is to retrieve it. So when you're storing it with the time zone it was stored. You're not doing you're not converting it all to like UTC and storing it. When you are retrieving it, you can do the conversion if you need to. So, because the idea is local time is local time, we don't need to really change it ever. So here, I'm actually going to select, let me do select star from store times, so you can see that indeed it's the same exact time, 3 a.m. on the 15th, because I'm in, GMT plus 2 over here. The offset is -5, and TZ is these 3 characters that don't mean anything except to us. So now what I can do is I'll concat, what I want is I want to get what the actual time is, say, in UTC. So what I'm going to do is I'm going to say select concat DT, so here's the date time. Let's say, I'm going to say minus interval OS hour, because if this is EST, then subtracting the offset gets me to GMT again. So DT minus interval OS hour, concat with a space and then the time zone, from store times. And so what that will get me is that will get me this time, convert the Eastern, add 5, and then it will say Eastern Standard Time, and this will add 6 and say Central Standard Time. So what we get here is, in fact, if I did something at 3 in the morning in both Eastern Time and 3 in the morning in Central Time, right, they were actual absolute times an hour apart. Local time is not. We're storing it in local time, right? So local time here, 3 a.m. in Central Time is the same as 3 a.m. in Eastern Time. I can convert it back like this, where I'm saying, hey, subtract interval OS hour, interval offset hour, time zone from store times, and I'm actually getting the fact that, yes, it happened at 8:07 Eastern Time and 9:07 Central Time. Same absolute time, right? Except actually this is now UTC, so I don't have to concat TZ, I can concat UTC. Because that's what it really is. It was 8:07 UTC and 9:07 UTC, because it's the same local time, different absolute times. But this can, basically show you that, yes, you can store those offsets. We should probably alter the table to have, if we alter the table to have the offset be a time, and have the offset be like -500, probably 00, and -6000, we can use the time addition functions to say add 5 to this. So it's a similar thing, it's just instead of interval OS hour, you would just use the time. So this is a way to use that stuff, and again, I use date time so there was no confusion with time zones or storing transparently as UTC. Then there's the it all works out approach, which is we don't do any conversion. This is what most people do because they just do it by default. Just store the date and times however they're stored, and if the date isn't 100% accurate for exactly what day or hour did it come in, because it's all going through Texas, right? So it's just storing it all in Texas time. It's still precise because it still gets the right time, the right absolute time, and it's relatively accurate to each other, right? So I hate saying absolute time means it's relatively accurate to each other, but it means that the same time in Eastern and Standard Time are an hour apart, because that's how they are absolutely. So 3 p.m. PST and 6 p.m. EST are the same time, right? They're relatively accurate to each other, but they're different times, so the same absolute time. For most companies, relative time is what's important. If you're the sysadmin or the DBA and they say, hey, things were really slow at 1 a.m., right, it would be a real pain in the butt to have to see, okay, do this offset to see how many orders came in, at 1 a.m. to see, okay, was it the volume of orders? And, if your web server is in Texas and your database server is in Texas, you're going to get operating system statistics local to that server. So it's local to the one server in the it all works out approach, as opposed to local to each person or whatever. I was just talking about this before. It's often less important to know that 3 to 6 p.m. is peak time in each time zone, and more important to know that peak time is 3 p.m. to 9 p.m. Marketing might care, right, that it's 3 p.m. to 6 p.m. in each time zone, so they can start having, you know, lunchtime promotions to get people to log on at noon instead of at 3 p.m. But again, in that kind of a case, you know, maybe you could store it twice, or you have special conversions for marketing, or, you know, you basically have to figure out what is my data going to be used the most for, and then do the least conversions based on that. Because the more conversions you do, the less performant your queries are. If you have to convert everything. So when you do something like this, you want to make sure that you know specifically whether your time is, like, is this 3:07 Eastern time, or is this 3:07 UTC, and when I need to convert it back, I need to convert it to Eastern time. So that's just a decision you have to make. You know, there's no right or wrong way to do it. Maybe the way you name the field, you know, maybe instead of date, time, offset, and time zone is, you know, I could say, okay, that's 3:07 Eastern time, 3:07 Central time, versus, you know, something like, to get it back to where it was, the offset is this, the time zone is that. So for most companies, relative time is important. You know, if you're, for example, an airline, the local time is more important, right? Because you don't know where everybody's coming from. It doesn't matter that I just got off a plane, you know, coming from Eastern time, and now I'm in Central time and I need to pick up a flight. They're going to give me the flight in the local time zone, even though my brain's still in Eastern time zone. So then there's the store it all in GMT approach. And I guess when I say GMT, I don't mean just GMT, I mean, you know, GMT and BST, British Summer Time. So store it all as a, you know, London Greenwich, you know, as a you know, Britain Greenwich time, like US Eastern time. Daylight saving time can still be an issue, right? We already talked about when you fall back 2 times volume between 2 and 3 a.m. It isn't much of an issue when you spring ahead. If you do store it all in GMT, which is what a lot of people do, or you know what, you know, store it all in as a user in Greenwich would see it, you would convert all, you know, events that you store and retrieve for people not in GMT. So if you're in Eastern time, you're doing 2 conversions, right? One to convert to GMT to store it in the database, one to convert back when I see it. However, it's easier in that case to let the user change their display preference. Since you're computing it twice anyway, you're always converting on storage and retrieval, then it's a lot easier because it's just, okay, what's your offset change? Application-aware reports may not match application-unaware reports. For example, if everything's in GMT and you say, I got paged at 1 a.m. last night, which is Eastern Standard Time, and you're like, wow, well, there was no peak at, you know, 1 a.m., but our backups happened at 6 a.m. You know, that can certainly, you know, that offset can screw you over, especially when you've been up since 1 in the morning going, why is this working? The graphs are fine. Usually you look at the graphs and you're like, there wasn't anything at 1 a.m., but gosh darn, there's a lot of traffic at 6 a.m. How come I didn't get paid? Oh, there's that offset. So usually it's not so much of a big deal.
Well, I was given the task to figure out how often the Unix, we were concerned that our GPS units were not always collecting UTC. So I went and looked at the data, and sometimes at exactly 8 o'clock GPS time, the 8 o'clock at the collected GPS time in the database that I was looking at, it said that it was exactly 1 day off. So it would say, and when I...
So it would say it was 8 a.m. instead of yesterday instead of 8 a.m. today?
It was saying it was 1 day off, exactly 1 day off.
Ahead or behind, yeah.
Exactly 1 day ahead, and then the next reading would go back to where it belonged plus a minute, because it was the next minute's reading.
So 8 o'clock would be, so there was never an 8 o'clock of today. The 8 o'clock of today was really 8 o'clock of yesterday.
Well,
but 8:01 is of today, and 8:08
well,
and 7:59 is of yesterday.
well, where this application where thing came up was the data was collected on a server running Pacific with daylight, support enabled, and then I copied it onto my server, which always runs UTC. So it was actually at midnight when it ran, and as
Right.
it turns out, the GPS unit on some midnights, instead of reporting all zeros,
it reports 24:00:00, and MySQL said that's a date plus 24 hours.
Yeah.
Awesome.
It was fucking awesome is what it
But
was.
see, that's the kind of thing where that's a little harder to figure out. And that's a much better example of, oh, application aware versus application unaware. But basically, you beat yourself over the head.
It's like
so you're
overflow,
oh, midnight.
something overflow, some, yeah.
Well, the way
It's
it's
But if-
zero,
I mean, if
zero
it-
versus two zero representations, that type of thing.
Right. If it was, at midnight that it happened, you'd figure it out right away. So then there's a stored all in UTC approach. So all time values are converted for storage retrieval, but they're converted to UTC or they're already in UTC because they're timestamps. It's harder to set up properly. You are doing the double conversions and whatever, so it's less performant. But it may be the only way to have true unified reporting is if everything is done in UTC. You still might have some things where your application and servers are different from your brain. So when you say, well, what happened at 1 a.m. that I got paged? Because I just hit OK and went back to sleep, but it did page again, so I was fine. But then now I want to see what's happening because now it's Monday or Sunday morning after my long Saturday night, and I want to see what happened. So there still might be that brain functionality missing. But most companies don't want or need to spend the time and effort necessary on this. More and more people are. Because again, if you're Amazon.com, do you really want separate databases for every time zone? Or separate tables for every time zone? So when you do your financial or separate queries to say, okay, group everything by time zone so that our fiscal year is done. Then again, how does a company deal with something when they say, we ship by 3 p.m. the next day? The next day what? In my time or your time? It's already 3 p.m. the next day in Australia,
Separate view from the state. That is the approach, and
Right.
that's
So again,
Correct.
timestamp can be dangerous because it doesn't. And it doesn't do it transparently. So you don't know it doesn't do it. I mean, before I researched this, I kind of knew that there was something in MySQL that might store in UTC, but I thought it was like everything. I thought it was timestamp or date time. It's one of these things where using times and time zones can be tricky. And you say something like, you first see these stored all locally approach and you kind of laugh, and then you're like, maybe that's kind of the way to go. Maybe that's just easier to just store it however it came in and save it with the offset, and then whatever I need to do, right? You're always going to convert it on retrieval anyway, so why not just not bother to store it on storage? It's at least a little bit of safety. But again, anytime when you're storing it with the time zone, if you're storing it in non-UTC, then you have to deal with daylight saving time stuff. So it is a little harder to set up properly, but once you start thinking about everything and, either say, dear God, never change the server time, please, and then you can use timestamp to your heart's delight, or don't. Or, just always use daytime.
military like it.
Yep. What most companies do is by default, they'll do the it will all work out approach. If they need to reconsider, they'll use the stored all in GMT approach until they get burned by daylight saving time again. In which case they might do the stored all in UTC approach. Very few companies do the stored all locally approach, but I think you might see that a lot more, or just die away depending on how the whole global economy thing works and how the global, when you have a 24/7 shop, you don't have an end of the day. So how do you figure out, how do you do your taxes? How do you figure out, when the end of 2009 is? So some problems, we've already talked about this, when the server time zone changes. Stop MySQL, change the time zone, then start MySQL, run the tests. Don't change the time zone on the server, change the data, then restart MySQL, because you might be surprised if the data doesn't do what you want it to do. Stop MySQL, change the time zone, start MySQL, look at your data and make sure it's the way you want it, and then if you're like, oh, well, I just, converted from Eastern to UTC, so let me add 5 hours to all the times, because that's what they should be, you don't necessarily want to do that if they're timestamp times. So stop MySQL, change the time zone, start it, check your data, then change anything. There are problems when the application servers, web servers are different from each other, the database servers, especially if you're just using the just put it in there methodology. And the real question is, what do two events at the same time mean? If you are in the health insurance industry, midnight PST is the same as midnight EST. It's a midnight. If you're in the hospital at midnight, we're gonna figure out whether or not we pay you for that overnight. If you're in the hospital at, 3 a.m. EST, but you're in a hospital in, it doesn't matter that our server's in EST if you are in the hospital in PST. Even though it's 3 a.m. EST, it's midnight PST, and that's what counts. Is that the same as 6 p.m. Eastern, the same as 6 p.m. Central? Or is 6 p.m. Eastern 5 p.m. Central? Look at TV. TV is really weird, right? A lot of the TV in Eastern time is the same absolute time that it shows. NBC will show the same program at 8 p.m., 7 p.m. Central, right? But Pacific time, it's 8 p.m. again. It's prime time in Pacific time, except for, when the Emmys come on. Sometimes you get the president of the company wanting to see the reports in his time, or marketing people wanting to see it in their time. They don't care if it's 6 p.m. local time. They want to know when they have to send their emails, and they care about that in Eastern time because they work in Eastern time. So they want to know, do they have to stay till 9 p.m. to send out the emails to the people on the West Coast? They don't care that it's 6 p.m. there. Now we're going to get into some of the interesting stuff. So I've repeated this slide. It was like slide 7 or 8. When MySQL starts, it finds the OS time zone and sets the system time zone variable. By default, the time zone variable is set to system and the system time zone is used. If the operating system time zone changes, MySQL needs to be restarted for the timestamp variables to change, but only timestamp data type fields change, not date time. So now, let's talk about changing the default MySQL time zone. You change the default in MySQL safe. You can change the time zone off option, not time_zone, time zone in MySQL safe. Or you set the TZ operating system environment variable before you start MySQL D or MySQL safe. The values that you can use for TZ name are system dependent. And you can also do set global time zone equal to time zone, or as we saw, offset. The values that you can set for these depend on the system time zone, which you're going to load into tables. So you can set the time zones to offset. So we've already done that. Where you set it to +7 or -10.5 or whatever you want, 10:30. So we've already done this, set the session time zone. In fact, actually, let's do this, although I don't think it's going to like the smart quotes. Nope, that's just fine. If we select now and UTC timestamp, paste, we get, the time zone of -8. So here's the UTC timestamp is 1 a.m. and -8, you get 17. Is that right?
Yeah.
Okay, thank you. Yeah, because it's 25. Thanks. So we've already seen that the timestamp field will be different and the date time field will be the same. So this again is still 7 p.m., but now this is 4 p.m. And if we do this, we can see the global time zone and the session time zone. So the global time zone is system, the session time zone is -8. And we might want to also do select or show variables like system time zone. And that is in Alaskan Standard Time still, even though I've already changed it back. Here I didn't restart MySQL when I did that. So, set session time zone changes it for that session only. Otherwise, it goes back to what the global is. It does affect the now, sysdate, and timestamp, the now and sysdate functions, and so also the current timestamp function, and also timestamp data types. It does not affect the UTC timestamp, nor does it affect any datetime data types. So, if I go and restart this MySQL server, and it's going to pick up that the system is now in Eastern Standard Time, and I do a select UTC timestamp, it's still going to be in the same kind of hour. It'll be a couple of, it'll be like a minute later because I've restarted MySQL. Using name time zone. So let's say we want to use EST or US Eastern. Now, there's a difference between US Eastern and EST. EST doesn't change. EST is always an offset of -5. US Eastern uses an offset of -5 in the winter and an offset of -4 in the summer. Right? US Eastern uses EST in the winter and EDT in the summer. So EST and EDT never change. They're always an offset of 4 or 5. We can, get confused by this because we say, oh, I'm in Eastern Standard Time. Well, you're not. You're in US Eastern, which happens to be right now, Eastern Standard Time. But if you set your time zone to Eastern Standard Time, what you end up getting is you never get daylight saving time because Eastern Standard Time isn't affected by daylight saving time. It just is disabled when it happens. So, if you want to use name time zone like US Eastern, so note that EST is not the abbreviation for US Eastern. If you want to use that name time zone US Eastern, you have to load information in the MySQL system database. There are 5 tables. And they're all joined by a time zone ID usually. So you have a time zone ID, and then the time zone table has a time zone ID and a flag of whether or not you should use leap seconds, yes or no. The time zone name has a time zone ID in the name, such as US Eastern. Time zone leap second basically has the correction and transition time if that specific time zone uses a leap second. Time zone transition is when the transition time happens, and then it has a time zone ID and a transition type ID. And here is actually where you get the offset. So you get, here's the offset, so -5, -6, plus 10.3, 10.5, whatever. Is DST abbreviation. So the interesting thing is, how do you load the time zone info? Well, you can download the tables from dev.mysql.com, downloads time zones.html. But the right thing to do is use the time zone info that the directory has, that the operating system has, excuse me. User share zone info is not a file, it's actually a directory. So Linux, Sun Solaris, FreeBSD, Mac OS 10 all have that. There's a utility called MySQL tzinfo2SQL that you basically run on the user share zone info. I actually have an example that I'll show in a second, so you can pipe it right into MySQL or you can output it to a file. If you download the tables from MySQL directly, you just get the MyISOM tables and you just copy those over. You want to reload periodically. In 2007, for example, the dates that DST changed, the dates that data saving time changed were changed in the US and Canada. Some countries change it like every year, so you want to come up with a plan of, if you're serving a global community with these time zones, then you might want to come up with a plan to update them frequently. If you're only serving the US and Canada, probably you'll know when the time zone changes.
But if you patch your operating system, will that solve that problem, or you still have
Nope.
to do it here?
Nope, because when you patch your operating system, you have to reload the table. So when you do MySQL tzinfo to SQL on user share zone info, that makes an SQL file. It makes insert into commands from what's in zone info. So once you import that, then you just have static data. So if you patch your operating system and get different zone info files, you have to run this tzinfo to SQL again, because it's new files to make the SQL from. This is a one-time run and one-time load. There's no way to magically link the tables to files on the disk, and so when the files change, the tables change. So that's why you have to reload it periodically. It's just as easy as reloading it. And if you don't update your operating system, you won't get the new stuff from zone info. So, you don't want to necessarily have a policy to say update it once a month. You might want to have the policy of whenever you patch your operating system, update these time zone tables. But they give you huge, huge convenience. So this is how I actually did it on a system. I did MySQL tzinfo to SQL, user share zone info, and cat that into timezone.sql, just a flat file. I got some warnings, unable to load, some of these time zones, and then I just imported it back into MySQL, and I did that on my Windows server. So testing time zone info. So let's. The one big problem is that you have to kind of know what the name is. Oops. Paste. There we go. Use MySQL. So select time zone ID from time zone name, where name is US Eastern. I get 561. If I did something like where name equals EST, I get 360. If I do something where I get, where name like percent Eastern percent, then there are a whole bunch of them. So if I do a select star, I'll get the time zone ID and the name. And you can see there's Canada Eastern, US Eastern, POSIX Canada Eastern, POSIX US Eastern, write Canada Eastern, write US Eastern. There's some standards committee that makes a whole bunch of these. If you really want to know, there are almost 2,000 different time zones, 17, 18. So that's the problem, is that if you want to figure out, okay, what's like the one for, you know, the Ukraine? Well, I don't know, is it like Ukraine? You can like look through all of them, or you could ask someone from the Ukraine, or you could get what the standard is. So right here we actually had values of, what was it, 561 for US Eastern and 360 for EST. So we can actually look at the time zone transition type, and I'm looking for the offset. Is it daylight saving time and the abbreviation? And I can do it here, it's not a big deal. Where it's 561, there's 4 different values. So where it's US Eastern, right, there's actually 4 different offsets for Eastern time. There's EST, right, which is not daylight saving time, and the offset is negative 18,000, which is seconds. So if I do select negative 18, 1, 2, 3 divided by 60 divided by 60, and then negative 14400 divided by 60 divided by 60, 18,000 is negative 5 hours, you know, negative 5, and this is negative 4. So, okay, these two I understand. Eastern Standard Time, EST, is negative 5 hours offset. Eastern Daylight Saving Time is daylight saving time. The offset is negative 4 hours. I have no idea what these are. They're probably older abbreviations, or perhaps newer ones, or ones we don't use, or whatever.
Where's the transition dates?
The transition dates are in the transition timetable. So if we want to say, select star from time zone transition, right? Select star from time zone transition, where time zone ID equals 561. We're getting a whole bunch of them.
Well, I'm interested in what the transition dates would be for those two ones we don't know about. That might be interesting.
Okay, so let's do select star from time zone transition type, because we want the transition type ID as well, where time zone equals 561. So we have the transition type ID is 0123, and the time zone ID is there. So we want now select star from time zone where time zone equals ID 561, and transition type in 2 or 3.
ID. Transition type ID, or do you need the ID?
I do. So these are the transition time. Now negative, these are timestamps. So negative means this basically was, you know, 1940 something or other. So if we do select from Unix time, now again, remember how I was saying, sure you can store timestamps, but they're really annoying when you need to look at them. Well, guess what? They're really annoying when you need to look at them. Oh, so that's null. Let's see. So, if I do positive that many seconds, it's 1997. So if I do select time diff, this minus, let's say, 1970, no, string, 1970, 0101, 000000. So this is getting the actual time difference. And of course it won't do that. Let's just do date diff, just because we don't really care about the time. We want to know, like, when was it? What year was it? What day was it? So we have 10187. So now we want to do select 1970, this, minus interval 10187 day. And that was February 10th, 1942.
World War II. That's what
approximately. So,
they made the change during the war.
Eastern
Oh, Eastern Wartime.
Eastern Wartime. Now it makes sense. Anyone want to guess what EPT means?
Eastern Peacetime.
It could be Eastern Peacetime. I don't know.
I thought it was POSIX, but no.
No, but it's still 7,000, so, you know, maybe it is after peace was,
That's it.
And,
who knows? We shall find out. 8905, 8905. and that was 1945. Maybe it was
Yeah,
peacetime.
peace.
We actually saw the time zone ID of 360 as well for the name of EST. So let's see what is in time zone transition type where time zone ID equals EST. And let's not put any extra quotes. And we have one warning, show warnings. Aha, because it's not EST, it's going to be 360. So there's only one, right? For where it was 561, which is time zone Eastern, US Eastern, we have 4. When it's EST, there's only one offset. So like I said, EST doesn't change. But if we look at there we go, where time zone ID equals 360, let's see, this may not even be a valid date. It may not even be a valid time. So there was no transition to or from Eastern Standard Time. I think it's just there for simplicity's sake, because if we look at select time star from time zone name, where name equals EDT, we get nothing. But CST, we get nothing. So there was an EST, and I think it's just there for simplicity's sake, but there's nothing in the transition time. Now there is a US/Central. Now knowing this pattern, we can say, okay, show me like, US %, and we see, okay, we've got Alaska, Aleutian, Arizona, Central, East Indiana, Eastern, Hawaii, Indiana, Stark, Michigan, Mountain Pacific, Samoa. And guess what? That's all your US time zones. Now
Yeah.
granted, it's magic, but that's because it's from the zone info stuff. So now here's the interesting thing. Because I have the time zone tables, I can actually set my time zone to US Central. I couldn't before. I can show you, I can truncate the tables and show you that if you don't have the tables in MySQL, it'll be like, oh, I don't know what you're doing. But it magically does all the joins it needs to figure out the right offset based on US Central. So now this, US Central, will have the right time, assuming the time zone tables are correct, with daylight saving time. So this is what, Don, you want to do, is you want to set the session time zone to something like US Pacific, and then instead of using offsets to convert, you can use this stuff, time diff, there. So what I'm doing here is I've set the session time zone. I want to select now, and then the time diff of now and UTC timestamp. And I should get the offset, which the offset should be central, whatever the central time offset is, which is 6 hours. If I was doing this with when I was in daylight time for central time, if it was in CDT, the offset would be -5. So US Central gives you the right thing. And the reason it gives you the right thing is, remember when we looked at ID 561 and we had 235 rows in set? These times are all in the future. So you can see here you've got 0101. This is when it changes. So it turns off at this Unix time, and then it turns on at the next one. So
I'm about to do a TZ convert on every field because this is year-round data, and it was year-round data collected with daylight savings turned on, and I want it all to be UTC when it's done.
yep,
So I have to do a TZ convert on every I have to do TZ convert on 3 columns for 140 million rows.
yep.
So it'll be,
So it'll take a while.
yeah, I think it's going to be 5 days to run.
These timestamps actually correspond to the year
Like it has even before
2035.
Windows box.
So when in March 11th it turns off, and on November 4th it turns on in 2035. So all of those 235 rows up here, basically are going until the end of the epoch, which is why you need to reload, because if it changes, all of the ones from then on are going to change.
Reload what?
Reload the time zone tables. So for example, this is actually correct for what's going to happen in 2035, assuming nobody else in the US and Canada changes what happens.
Like
If-
you did in 07.
Right.
You
Right.
changed it in 07,
We changed it in 07, right.
and that might happen again.
Right, and so after we changed it in 07, when Red Hat or whatever it is where I got this patched their operating system, they changed the zone info files to say, instead of in 2008 when it changes, instead of being April and October, it's now March and November. And now in 2009 and 2010 and 2011, all the way up until we run out of bytes and the world ends in 2038. So we have a few more slides to just blow through here. The convert time zone can use offsets, which we've shown. It can actually use these things. So you can actually use convert TZ, Don, with the names. So you can say, hey, you know what? This field, either now or from this table, is using US Eastern, and I want to convert it to GMT or UTC or whatever the right name is. And you can mix both. You can actually say, I want it to be US Eastern and 0 or session time zone and 0. So convert TZ is going to be your friend. Most importantly, be careful. That's the most important thing. Be careful. Know what you're doing. Don't forget about existing data, as we see Don's problem. Mass conversions can be done like this: update table, sub field equal to field, the interval offset hour, or you can use convert TZ, or you can, if you really want, you can join the tables and find the right thing from offset type yourself. I would use convert TZ if you have the time zone tables. But in this is only replicated properly in MySQL 5.0 and up, so you're safe on this. But if you're using replication and you use convert in like a session time zone, it's specifically said in the MySQL manual that it's only like 5.0.4 and up or something. So it's any version that you would probably be using. But that's just a note. And then learn more, experiment and test. I mean, the only ways to do it are to test. We looked at some things. Well, what happens if you do this? Well, you know what? I can theorize all I want, and I can say I think this is going to happen. But the best way to do it is just to try it, because you can think and take an hour, or you can try it and take 5 minutes and say, aha, I guess it did this. Because I can come up with ways where it might do this or it might do that. And what I need to know is, this is me anyway, which one will it do? Because I could see how it might convert things or it might not convert things. Oh, okay, I guess it does convert things. Now I know.
Would anyone know whether Oracle acts the same way as MySQL? I mean, is it similar? I know you're not.
Oracle, you can specify things with a time zone. So I believe in Oracle, if you specify things with a time zone, then it stores it with that time zone, and then you can do conversions and it does the right thing. And if you store without a time zone, I think it's just local time and it doesn't do any implicit conversions.
Yeah.
So, and then you can go to the manual for time zone support. Definitely test, especially if you have a master and slave that are in different time zones, or if you have the application web server that's in different time
That's
zones.
interesting, yeah.
Um,
I think about disaster recovery,
yes.
which is very commonly done, you know, in different locations.
Right.
Now you restore it.
Right,
create
and it'll
another
convert
disaster.
Right.
Which is why I'm a fan of UTC, and then having it only
Right.
on extract do you do the
Exactly,
conversion
yeah.
to-
That's why it is better. Yeah. Yeah, that's interesting.
Right, but even if you convert to UTC and extract only on, and convert only on extraction, if you store it as a timestamp, it still matters what the
Local time.
the server time zone is. All right, so I just want to show you one thing. I've truncated the time zone, all the time zone tables that in the MySQL database, and now I'm going to set my session time zone to be a named time zone of US Central. Oh, why do you do this to me? Oh, it might load it on. I might need to restart MySQL, but let me see. Let's see, select now. And let's now set it to US Eastern. You know why? Because it was Central before. So now I can't set it to US Eastern because it doesn't know what that is. I can't set it to EST because it doesn't have any time zones in there. But I can say, -500. So that's the end of time zones, and I was very excited actually to do this presentation because I learned a whole lot. And everybody pretty much says, don't mess with time zones in MySQL, just use the system time zone. And really what it should be is, mess with the time zones. Maybe you don't need to load the time zones, right? But you should mess with the offsets because you should know what you're doing, because MySQL is going to mess with them anyway if you use timestamps.